Alright, so I'm making this video so we can go over the word problems on your review. To start off, I would like to reiterate a certain point. If you have an angle of elevation problem, your triangle is always going to look like this. It's going to be a right triangle, it's going to look like that. And the angle of elevation is always going to be the angle on the ground. If you're unsure whether or not it's an angle of elevation problem, look for whether or not the person is looking up or down, and if the angle is on the ground. Anytime it says angle with the ground, it's an angle of elevation problem, and you should draw your triangle the way I've just drawn it. Now, if you have an angle of depression problem, that's going to be anytime your viewer is looking down, your triangle should look like this, and this is the angle of interest. So this is key information that we're going to use throughout the entirety of this video. So we start with the first question. It says, a ladder leaning against the house makes an angle of 67 degrees with the ground. So the angle is on the ground. It is an angle of elevation. The foot of the ladder is 8 feet from the foundation of the house. That's the bottom of the house. How long is the ladder? Approximate your answers to the nearest foot. So we're going to draw a triangle like this one, right here. Might need to make it a little bit smaller. So here's our triangle. And so there's our triangle, and it says the angle made with the ground is 67 degrees. It says the foot of the ladder, this part, is 8 feet away from the base of the house or the foundation of the house, that far. So that's 8 feet. And then it says how long is the ladder? Well, the ladder isn't going to be straight up and down the vertical. The ladder is going to be the hypotenuse. So we're going to use trig to find that length. Eight feet is the side adjacent to this reference angle. X is the hypotenuse. So adjacent and hypotenuse we are going to use cosine. Cosine of 67 degrees is the adjacent side, 8, over the hypotenuse, x. Well, since our variable is on bottom, we are going to switch. X equals 8 over cosine of 67. Solve for x and you found your answer. So then we get to the next word problem, which is a very challenging word problem. Elizabeth is in the sky deck of the Sears Tower overlooking the Michigan Lake. She sights 2 sailboats going due east from the tower. The angle of depression, so if it's angle of depression, we need to draw our triangle like so. She sights, the 2 boats are, the angle of depression to the 2 boats are 42 degrees and 29 degrees. If the sky deck is 1,335 feet high, how far apart are the boats? So we have 2 angles of depression, so that means that we're going to have 2 triangles. So here's our first triangle. there's this lady. There's this lady over here in a tower. She's looking down at a boat. Okay, that angle of depression that she's looking down at is 42 degrees. Now it says the sky tower is 1,335 feet high. So anytime we're talking about how high something is, it's going to be our vertical leg. And it says, how far apart are the boats? So how we're going to do this, we're going to work these problems separately, and we're going to find the distance from her to the boat. And then we're going to find the distance from her to the other boat. And it'll be a different number because there's a different angle of depression. Once we find these two distances, we'll subtract to find out how far apart the boats are. Traditionally, when you approach a problem like this, you would actually draw your triangles overlapping. And one of them would be a tiny bit longer or shorter. So once we find those two distances and then subtract, then we'll be getting how far apart. This is what the question is really asking for. This is what the question really wants to know. So I'm going to do all that took me forever to do, to draw, just so we can solve for those two distances. We're going to end up using pretty much the exact same equation. If this is our angle, we're given the side opposite, and we want to know the adjacent side. Opposite and adjacent, we're going to use tangent. So tangent of 42 degrees equals opposite 1,335 over our adjacent x. We have to switch. X equals 1,335 over tangent of 42. Since it's the same problem-solving process, we can then figure out that the other length would be the same thing, except the angle inside tangent is 29. So you'd plug both of those in your calculator. And you get their distances. This 42, tangent of 42, is going to tell you the distance of the closer boat. And this tangent of 29 is going to tell you the distance of the boat further out. So one boat is 2,408.4 feet away from the tower. The other one is 1,482.67 feet away from the tower. When you subtract those, you find how many feet apart the boats are. So we subtract that, and then we get 925.74 feet apart. The next problem also involves two triangles. It's a highly involved problem, and so here we go. There's a woman standing. Woman standing. And she's standing 12 feet away from a sculpture. It's a sculpture. It says the angle of elevation, so elevation is looking up from her eye. So this is her line of sight. This is not her line of sight, but this is the horizon that matters. When she looks up from her eye to the top of the sculpture, the angle of elevation when she looks up, the angle of elevation is 30 degrees. And then the angle of depression to the bottom of the sculpture is 22 degrees. It says, how tall is the sculpture? So we need to find how much taller it is than her, and then how much, and how really technically how tall she is, but how both of these opposite legs. We got to find both of those opposite legs. And so in order to do that, we're going to use trig 2 times. This leg, this adjacent leg on both right triangles is 12 units long, 12 feet long. So on the first one, 30 is the reference angle. 30 is the reference angle. 12 is the side adjacent. We need to find the opposite side, so we're going to use tangent. Tangent of 30 is opposite x over adjacent 12. 12 tangent of 30 equals x. Now we need to find the length of the bottom portion of the sculpture. So if we find the length of the bottom portion of the sculpture, we're going to do pretty much the same thing. 22 is the reference angle. 12 is the side adjacent. Y is the side opposite, so we're going to use tangent again. But now we have tangent of 22 equals y opposite over adjacent 12. So we get 12 tangent of 22. We place both of those in our calculator. Twelve tangent of 30, and then 12 tangent of 22. So you get 6.9282 for the top part, and then 4.8483 for the bottom part. So it says how tall is the sculpture? So we need to add the top to the bottom. And you end up getting about 11.78. But it says to the nearest foot, so the sculpture is about 12 feet tall. All right, now we're going to take some time to do the last word problem together. The last two word problems together. The first one is this word problem above about the slide. A slide is 4.4 meters long and makes a 33 degree angle of elevation with the ground. How tall is the slide? So we're going to draw a right triangle like normal. It's an angle of elevation. It's a right triangle. So if it's an angle of elevation with the ground, it says that that angle is 33 degrees. And the slide is 4.4 meters long. That length is going to be one of the sides of our right triangle. We have to figure out which one. Well, we're trying to figure out how tall it is. Tall is a keyword for up, down. We're trying to figure out how tall it is. The side is not flat on the ground, so it's not going to be the other leg. That 4.4 meters is the hypotenuse. So to figure out how tall the side is, x is the side opposite, whereas 4.4 is the hypotenuse. Opposite and hypotenuse, we're going to use sine. Sine of 33 degrees equals the opposite side x over the hypotenuse 4.4. To solve for x, we're going to multiply both sides by 4.4 and end up with 4.4 sine of 33. We type that in our calculator. And we find that the side is approximately 2.4 meters tall. Now we have one more word problem, and it's about the lifeguard. A lifeguard sees a swimmer struggling in the surf. The lifeguard is 12 feet high above the water, and the swimmer's position makes a 10-degree angle of depression. So if it's an angle of depression, that means we're going to draw a triangle upside down, and the angle is going to be in the top corner. What is the horizontal distance from the swimmer to the lifeguard? So let's draw our upside down triangle. Lifeguard is sitting in a cool lifeguard chair. He's sitting up here. And he had a ladder to get up to his chair. Here's the lifeguard with his cool chair. He's looking down at a swimmer who's probably not swimming very well, thrashing all over the place. So when he looks down, that angle of depression is 10 feet. We know that from the water, the lifeguard is 12 feet high. So how do I put that on my right triangle? We're going to put that on the vertical leg, 12 feet. It says, what is the horizontal distance from the swimmer to the lifeguard? Horizontal distance. So we figure that out using trig. Here's our angle, our reference angle. 12 is the side opposite, and we want to find the adjacent side. Opposite and adjacent mean that to solve, we need to use tangent. Tangent of 10 degrees is the opposite side 12 over the adjacent side x. To solve for x, we switch. X equals 12 over tangent of 10. So we put that in our calculator. And 12 over tangent of 10 is 68.05 feet. He's 68.05 feet away. So, if that swimmer is drowning, that lifeguard's going to have to swim 22 yards over to get that swimmer. Or 68 feet, which is a bunch of feet. So, all these word problems are done. If you're stuck on the pond problem, the basic idea is we're walking the 34 plus 41 meters. So a total of 75 meters. It says how much shorter. Shorter is the key word that we're going to need to subtract. Is the distance to walk through the pond. The distance through the pond is the hypotenuse. which you can find using Pythagorean theorem. Email me if you still have any questions. This question is just a review question, reviewing what you know about spherical geometry. And that's all, folks.